Hey guys, welcome back. This is the second video for Chapter 1. I'm going to review some of the questions from Quiz 2 in the Schoology page. So this really goes over lessons 1.5 through 1.7, dealing with equations and inequalities. So we start here with a Queensland toad traveling 10 meters per day. Either that's a typo or this toad really is not traveling very far. So we're told 1 meters per day. Per tells me division, and I can set that up as a ratio if I would like. Now, the problem here is it ends up asking me how far will the toad travel in hours. So what I see is I somehow have to take my days and convert it into hours, so I'm going to need to use some kind of conversion factor. Now, a nice thing to do here is if I can reset this ratio and go ahead and convert before I do the problem, that will make things a lot easier. So since days to hours is an easy one, I can, instead of using 10 meters per day, I can use 10 meters per 24 hours. Now this is the exact same thing. I've not changed anything except for changing one of the labels so that it would be hours instead of days. So now what this problem is asking is how many meters, so I'm just going to go ahead and use x for our standard variable. How many meters will they be able to travel in 5 hours? Now we have options. We could either figure out a unit rate first, and then once I know my unit rate, multiply that by 5, because my unit rate would be meters per hour, or when I set up this ratio, I can just cross multiply to solve. So if you are not familiar with cross multiplication, or if you haven't done it in a little bit, I'm going to multiply my values that are diagonal each other, set that equal to my other values that are diagonal to each other, and I am going to get 50, because 5 times 10, is equal to 24 times x. Now to isolate that x, since there's multiplication holding it together, we want to do the division, and we get x equals 50 over 24, which comes out to be 2 and 2/24, which is really 2 and 1/12, which comes out to be 2.0, now I lost everything, 2.083 if you care as a decimal. And that would be meters. So in 5 hours, that toad could travel approximately 2.083 meters. Continuing on in the same type of problem, solving unit conversions, we have that a football field is 100 yards long, not counting the end zones. And we want to find its length in miles. So if you were going to run from one 0-yard line to the other 0-yard line, how far would you have gone in miles? Well, we've got yards, and we need to go to miles. So we have yards to miles. However, my conversion factor is given in miles compared to feet. So I don't really have yards to feet. I could either convert these feet into yards and figure out a conversion ratio that way, or I can go from the yards that I have and go into feet before I go to miles. Since the conversion factor that I have is in feet, it's almost nicer, not right versus wrong, but almost nicer to just go ahead and say, I can turn my yards into feet, and then I can turn my feet into miles. And that's how I can make that conversion. So really, this football field, when they tell me it's, I'm going to go ahead and say, they tell me one field is 100 yards. Just like what we did on that first problem, I know automatically that that's really telling me one field is 300 feet, because we know that there are 3 feet in 1 yard. Now we're going to use this conversion factor in a method that my high school chemistry teacher loved to call stoichiometry. My ballot is still out whether that is real or whether she made that up. But when we want to cancel out feet and end up in miles, I know that miles has to end up in my numerator. So I really actually have this set up wrong, because if I set up miles in my numerator, I need to cancel out feet, which is in the denominator. So to cancel out feet in the denominator, I got to have feet in the numerator. So I actually built this backwards. I need to relate to my one field being 100 yards, I need to flip this, because really this ratio that I start with, it doesn't matter which way I build it, it matters where I'm going with it. So what I'm technically starting with, the value that I need to convert, is my 300 feet being equal to the one field. So sometimes when we start, we might start upside down, and we have to realize that by saying the unit I want to end in, what I want for my answer, has to end up in the numerator. So to cancel out these feet, I'm going to put feet on bottom. My conversion ratio is that 1 mile equals 5 tomato, or 5280. If you've never heard that before, 5 tomato. 5280 is feet in the mile. So this leaves me, we'll change colors again, with 300 over 5,280. Let's check our labels. Well, we had feet on top and feet on bottom, so feet divided by feet. Those reduce out to 1. I have miles per field, which is really what I want. The answer of miles per field will work out perfectly for me. So really, I just need to do my 300 divided by 5,280. And we get, I wonder if that has a nice fraction. So, fraction decimal. This reduces out to 5/88, or as a decimal is 0.0568. So about 5/100ths of a mile. So if we were going to use approximate math on this, if we say 5/100ths, if you run the field 20 times, you will have ran over a mile. So just over, but if you run the field 20 times, you will run just over that 1 mile. Again, all of the answers I capture into a PDF document, and that PDF will be posted in the Chapter 1 folder as well. So this proportion here, we're just going to solve it the same way that we solve any of our proportions. The first thing that we can look for, is there a nice direct conversion from the two values that I know, either the two values in the numerator or the two values in the denominator, or is there a nice conversion from numerator to denominator or denominator to numerator? And there's not anything super easy here. So since there's nothing super easy, let's cross multiply. So we're going to do 3 times x equals the 5 times 13. So you're setting your cross products equal to each other. I get 3x equals, don't use your calculator, 5 times 10 is 50, plus another 5 times 3 is another 15. So that is 65. To get rid of this multiplication, I'm going to divide. Now again, don't touch your calculator. Making your life way too easy. 60 divided by 3 would give me 20. I have another 3 in there, so that's 21. I get 21 2/3, or approximately, we should really use squiggly equals here, 21.67 if you want to round, or you could say 21.6 repeating if you want to write it in repeated notation. Number 4, I'm going to pause this and actually set up the problem, but again, we are going to cross multiply because we have expressions in the numerators. There's going to be no easy way to convert from denominator to denominator or numerator to denominator because we've got variables involved on both sides. All right, so in number 4, we start out by cross multiplying. So the 5 multiplies by x minus 1 and the 2 multiplies by x minus 4, leaving us with 5x minus 5 after we distribute and 2x minus 8 after we distribute. From there, you have 4 options, which makes your life really hard because you've got to make the choice. You can either subtract 5x to get rid of it from this side, add 5 to get rid of it from that side, subtract 2x to get rid of it from this side, or add 8. Now, this process will get easier as you do more of these, but I personally like to keep my variable values positive if possible, so I subtract or get rid of the smaller variable value in a way that will keep the variable positive over here. So when I combine those, I get 3x, I still have the minus 5. The 2x is gone, but I still have the negative 8. Now, to get rid of the minus 5, I'm on both sides going to add 5. That gives me 3x will equal -3, because remember, you're at a -8, going up by 5, you're still negative, and you're at -3. To compensate for the multiplication and get rid of it, we're going to divide by 3, and we get x is equal to -1. If we plug that back into the original, the fraction on the left should come out equal to the fraction on the right. So now what we have in this next problem is a concession stand sells 3 apples for $2. What's the cost for 10 apples? And we're assuming that the cost stays the same. So this is one of those tricky situations. Or like at the grocery store, if they say, if they say like 2 liters are 2 for $3, well no, 2 for $3 doesn't work, like 5 for $3, or weird things like that. So 3 apples for $2 is going to end up with an interesting situation, because sometimes they don't divide out evenly, and the third or fourth or fifth item or wherever you're at has to have like an extra penny involved so that we can do that rounding. So if I know cost and amount of apples, I like to set cost in the numerator. So I'm going to set up cost over apples. So cost of $2 over 3 apples. And I'm wondering what's the cost, so we'll just say x for now, for 10 apples. So this is like that situation where we're asking, is there a direct conversion bottom to top or bottom to bottom, top to top, anything like that? I mean, one thing that I could see is coming down, I'm multiplying by 1.5. So we could do that if we could go down, but that's pretty hard here since we know the denominator and we don't know the numerator. So instead, again, we can just cross multiply. So if I cross multiply, I get 20 will equal 3x. From there, we divide by 3. And I end up with x is equal to 20/3, which that divides by 18, so I get 6 2/3. Or my cost for 10 apples is going to be $6.66. That repeats forever. So if you were actually at the concession stand and they were really going to let you buy 10 apples at this cost, they would actually round your price up to $6.67, because they don't want to take that extra amount of money that you don't pay. They'd rather have you pay slightly more than what you were going to pay, and they get the profit. So this is just like if somebody asks me, I'll show you a receipt from Kroger or different times where like you have a $1.66, $1.66, $1.67, $1.66, $1.66, $1.67, because one of them has to round up and compensate for that infinitely repeating decimal value. Now, in my question down here, which is a solution, we have multiple choice. So you could guess check, but guess check is a lame method for solving. So we would rather simplify the inequality and think about it that way. So I'm first going to do the distribution because I have a value up against parentheses. So that gives me 3x plus 12 minus x is greater than 4. I can then combine my like terms. I have a negative x and a positive 3x. So when I combine those, I really get 2x plus 12 on that left-hand side is greater than 4. The only side where I have variables is my left-hand side. So go ahead and get your constants over to the right-hand side. So I'm going to subtract 12 to make that happen. I get 2x is greater than -8. This is where people make their mistakes. So we've got a negative number involved here. However, my variable value is positive. So when I go to isolate the variable, I'm dividing by a positive 2. In an inequality, if I divided by a negative, which I'm not here, but if I did divide by a negative, my inequality symbol would have to flip. I'm not dividing by a negative here, so my inequality does not flip, and I get x is greater than -4, which means x is going to be higher or more positive than -4. -6, -5, and -4 will not work because none of them are bigger than -4. -4 equals -4, but that's not the answer. -3 is the only value here that is more positive than -4. So remember, being greater than does not mean it's a bigger number. It's more positive. It's higher up the number line. So our last problem here, number 7, especially if you've not tried this on your own, I would advise that you definitely make sure that you're able to work this without my help. But if I rewrite the original problem, 6t minus 1 is greater than or equal to 4t plus 13. So I have variables and constants on both sides. So again, I'm in one of those situations where I have 4 options to start. What I see is I have both positive variable values, and I would like my variable to stay positive. So if I take away 4t, not 40, but 4t from both sides, that will leave me with a positive 2t, which is nice because then that's the only variable that I have left. So my inequality becomes that. Since my only variable is on the left-hand side, I'm going to treat that as my variable side and add 1 to both sides. I then have 2t is greater than or equal to 14. I can isolate the t by dividing by 2. I'm going to bump over so that I'm not writing underneath of my little video screen. I get t is greater than or equal to a positive 7. Now let's hypothesize, what if I had solved that in a different way? So, if instead of subtracting the 4t, let's say I didn't really put much thought, and I just started by subtracting 6t. I then would get negative 1 is greater than or equal to negative 2t plus 13. Well, now my only variable is on the right-hand side, so to compensate for that plus 13, I take away 13. That's going to give me negative 2t on the right-hand side and a negative 14 on the left-hand side. From there, we divide by the negative 2. Hopefully I don't end up writing under my video screen. Because now we did a division by a negative, this inequality symbol is going to have to turn around. So that becomes less than or equal to, my t stays on the right-hand side, my 7's over here, but now this says 7 is less than or equal to t. Sorry, if you did not see it, we get this over here, which when I turn it around is the exact same thing as t being greater than 7. So both of these answers are exactly the same. As you can see, the first method that we took was a little bit easier because we didn't have to flip the inequality symbol. But if you divide by a negative, that inequality symbol has to get flipped around. That's the end for the Chapter 1 formative assessment materials. So if you would like any more help, please let me know on Schoology, send me a message, something like that, email, text, anything like that. Otherwise, come in, take the summative assessment. Hopefully you can test out of Chapter 1, and we will move on. Have a great day, guys.